This lesson will review some content that you learned about graphing lines in Algebra 1. You may recall that the equation for a line can be written in many different forms, but the most convenient form if you want to graph a line is called slope-intercept form. And I want to point out that your book is different than most books. Your book uses the equation y equals a plus bx, where a and b are numbers. X and y remain variables. But I want to let you know that most books use the equation in the form y equals mx plus b, and that's the way I'm going to teach it in class, because that's what I imagine you'll see in college and in any other school or any other textbook. And when it's written in this form, m is the slope and b is the y-intercept. I want to alert you to potential confusion here. In the book's representation, A is the y-intercept and B is the slope. So your book sometimes is going to use B to represent the slope, and I'm going to be using B to represent the y-intercept. Fortunately, in most of our examples, those are going to be numbers, not variables anyway, but I do want to alert you to that possible confusion. If you need to graph a line that's already written in slope-intercept form, here's what you do. Well, you start by identifying the slope and the y-intercept. So in this problem, m, the slope, is 2/3, and b, the y-intercept, is -5. Notice it's not 5, it's -5. So when I go to graph that, first I'm going to find the y-intercept. 1, 2, 3, 4, 5. So remember, y-intercept means where the line crosses the y-axis. So there it crosses the y-axis at -5. Then I'm going to use the fact that the slope is 2/3 to find another point on the line. So I'm going to start at the point I've already drawn, and remember, slope is rise over run. So I'm going to go up 2, 1, 2, and over 1, 2, 3. And if I want a neatly drawn graph, I might go ahead and draw another point, up 2 and over 1, 2, 3. The more points you have, the more likely you're going to get a nice, neat drawing. So there's several points, and there is a line through those points. It's worth just checking after you finish. The slope on this is 2/3, which is a positive. So you want to make sure that from left to right, it's going uphill. Remember, if you have a negative slope, you'd want to be going downhill from left to right. So I always encourage you to check that after you graph a line. Now suppose the problem is the reverse. The line is drawn and you're supposed to figure out the equation. Well, let me switch the color here. So first I'm going to find the y-intercept just by looking at the graph. So the y-intercept in this problem is right here. So 1, 2, 3, 4. So it's +4. And next I'm going to look at the graph to determine the slope. Well, notice that it goes downward from left to right, so I know the slope is going to be a negative. And if you count it out, it's down 2 over 1. Down 2 over 1. And that pattern repeats, down 2 over 1. So -2 over 1, which we would generally write as -2. And then remember, the general way of writing an equation in slope-intercept form is y equals mx plus b, where m is the slope, so I'm going to put a -2, and b is the y-intercept, which in this case is +4. For your homework, I'd like you to determine the equation of each line represented here. When I created this graph, the equations went in this space right up here, but I cut those out, so you have to figure out what they are. And when you do this, would you either color code, or if you don't want to color code, you could also just, when you turn it in, write red, and then give me the equation of the red line, y equals whatever. Blue, give me the equation of the blue line, and green. Otherwise, I don't know which equation you intended to go with which line. Remember, to do that, you just have to look for the y-intercept and the slope, and then plug those into y equals mx plus b.